All right, guys, today we get into our first encounter with actual equation solving techniques. What we did yesterday is we looked at how do we know when something is a solution or not. And that is something that should remain a big part of your equation solving process. It should be huge because that's what you should be doing to check to make sure your answers are right every time. You should be plugging them back in and making sure they make the equation true. But now what we want to look at is some specific techniques for solving equations. And the basic idea behind solving an equation is first understanding what an equal sign means at the beginning of a problem, and then it's understanding how you kind of keep it that way. Okay? So an equal sign, what that means is you have the value of everything on the left-hand side is equal to the value on the other side. Now that doesn't mean they are 100% exactly the same. They're not twins. What that does mean, though, is that you have the exact same numerical value on each side. It's kind of like having 100 pennies versus 10 dimes. You have the exact same amount of money, and what you could probably do is, if I told you that, okay, over on in this hand, I have 10 dimes, and in this hand, I have 100 pennies. I'm telling you that these are equal amounts of money. You could figure out how much each was worth, right? You could probably figure out that, 10 of these pennies must equal one of these dimes. You could figure that out. So we've got the same kind of thing here. You're going to likely have lots of variables and things on one side, maybe both, and numbers all over the place, and you kind of have to whittle things down until you figure out, okay, the variable is equal to this amount numerically. And the way you can deal with that is balance. If you have the same exact value on each side, it's like you've got one of those old school hanging pan balances, where if you got the exact same amount of weight on each side, they'll be at the same level. And if one side's heavier, it'll drop. Okay? So let's say we had an equation like x plus 2 equals 5. What that literally means is we've got this mystery box x, and then we've got something that we know to be a value of 2. I'm just going to say it's two little boxes that weigh 1 each. Then over here, we've got 5 boxes that all weigh 1 over on this side. So the question is, how could we figure out how much that mystery box is worth? Well, you'd want to be changing things so that the balance is kept, because if it's not balanced, you don't really know how much it is. So what I would do is I would just remove these 2 boxes, and then I would remove 2 boxes from the other side as well, knowing that if I pick up 2 pounds from each side, I should still have the same weight. I'm left with x equals 3. So as long as I do the same thing to both sides of my balance, it stays balanced. Same thing is true with an equation. As long as I do the same thing to both sides of the equation, I will keep my balance. I will be able to keep my equal sign. So the question is, what is that same thing that we should do to both sides? What you kind of have to understand is you're trying to transform this into just an x, okay? So I'm going to throw up 4 examples, and we kind of want to think, how would we get these to be just x equals a number? Now you've probably done some of this before, which is great, but we're gonna look at it one more time here. So all of them use an x, a 2, and a 6, but we're going to definitely get some different answers here. So the question is, right now you've got x plus 2. Ideally, you don't want that 2 to be a 2. What do you want that 2 to be? What could you add to x to have it really just be x? Hopefully you're thinking 0. If we had x plus 0, that's the same as x. Well, how do you turn a plus 2 into a 0? You subtract 2 from it. Then we're left with x plus 0, or just x, equals 4. Same thing for the subtraction one. We don't want that to be minus 2. We want that to be minus 0. But from there, we would need to add 2 to change that into a 0. I think you kind of see what's going to be happening here. Now, over with the multiplication and division, it's a little bit different. We don't want to turn those 2's into zeros. We want to turn them into 1's. Okay, and since it's the way to change a 2 into a 1, we can't really subtract 1 from that. 2x means like we have 2 x's. But what we can do is we can cut those in half. We can divide it by 2. We can get x equals 3, because here 2 divided by 2 is 1, and we get 1x is 3. Same thing here, multiply both sides by 2, and we get rid of our 2, turn it into a 1, we get 12. The key is we want to use opposite operations. I mean, just think about it. If I multiply something by 2, dividing it by 2 will get me right back to where I started. So like here, I multiplied this x by 2. If I want to undo that multiplying by 2, I need to divide. Okay, so we're just working on all sorts of little one-step equations today. To get rid of a number in a one-step equation and just get x by itself, you need to do the opposite operation. So some examples. I'm just going to put up 3 examples, just 3. And one of them I'm going to make just extra special hard just for you guys. Okay, what I want you to do is try all 3 of these. There should probably only be one thing that you have to do to both sides to get it right away to be x equals the number. The third one, maybe you could do 2 things, but try all 3 of these and then come back to get your answers. I'm assuming you've tried them all, and for this one, hopefully you realize we need to add 2, because that's the opposite of subtraction, and we get x equals 7. 7 minus 2 is 5, that checks out. Here we're dividing by 3. We get x equals 5. Over here is the tricky one. We're doing 2/3 times x. If you keep in mind that we want to turn that into a 1x, what we want to do is we want to multiply by 3/2. Because that'll make this like a 6/6, which is the same as 1. So we get 18/2, or x equals 9. That one was definitely a tricky one. This method over here for getting rid of a fraction times a variable is called multiply by the reciprocal. And when you multiply by the reciprocal, you're multiplying by that fraction flipped over, because anytime you do that, you'll always get a value of 1. So that's it. I think those fraction ones are the most complicated ones. Try some practice, and you know, get ready to discuss some things with your group tomorrow. Obviously equations get a lot trickier than this, but for right now, this is your one step. Just keep those opposite operations in mind.